Okay, this is chapter 2, the lymphatic system and the immune system. Now, this chapter is quite lengthy, so I'm not going to spend all my time on every single subject matter. I'm just going to skip around. So make sure you read your book quite a bit. And I'm going to spend most of the time talking about immunity because that's what most people get confused on. So let's go ahead and look at your PowerPoint on slide 5. What the organs that are in the lymphatic system, you have your lymphatic vessels, your lymph nodes, your spleen, your thymus, and your tonsils. So those are the considered lymph tissue that makes up your lymphatic system. And the lymph vessels spread from everywhere through the tip of your toes all the way through the body, kind of like the veins. That's how the vessels spread. They perform quite a bit of things for your body. Mainly, they protect for infection when there's any type of foreign substance that enters the body, like a germ or maybe an actual object that enters the body. Stuff will go to the white blood cells will go to the area that is injured and cause the lymph nodes and the lymph vessels to carry lymph tissue, and that causes the area to swell, and there may be some pain and fever there. So that's the main use of the lymphatic system. Okay, so let's look at the next slide and talk about immunity. The two main types, and then we're going to drop it down into subtypes, are your non-specific defenses, which are your innate immunities, and your specific defenses, or your acquired immunities. Now, both of these, as you'll see in a little bit, are stuff that you actually acquire from being exposed to certain conditions or being vaccinated against certain diseases. The immune response, let's look at that slide. Disease-causing agents called antigens stimulate the immune system, the immune response, and antigens are considered the disease, basically. And then when it comes into the body, your body creates, Lord, my mind just went blank. Your body creates antibodies, to fight off the foreign invader or the antigen. So your body will get an antibody-antigen response or antigen-antibody response. And we hope that in most patients, unless you have some type of autoimmune disease, that this is a good response, and this will cause you not to get sick for every little thing that you're exposed to. Okay, different processes. We have humoral immunity, which is called the antibody-mediated immunity, and then we have cellular immunity, which is called cell-mediated immunity. So we're going to look into these a little bit further. Let's go on into innate immunity. This can be caused from physical or chemical barriers. It is caused by phagocytosis, which is, if you remember from A&P classes, the engulfing of a bacteria. Natural killer cells, which we'll talk about shortly. Fever, because you probably noticed when you've been sick, you've gotten a fever. Maybe you've gotten a paper cut, and you'll notice that it's warm to touch if it gets infected. That fever is a normal part of that process. Interferon is released, and then of course you have inflammation, and that's your white blood cells that rush to the area of suspected trouble, and they cause the phagocytosis to happen and hopefully kill the microorganism. Okay, let's look at natural immunity, otherwise called innate immunity. It's not specific to a particular disease. It doesn't require prior exposure. Okay, it's just something that can happen. It's something that you're born with. Let's go on. Let's look at slide 13, the inflammation slide. This kind of tells you about how the body reacts. If we have tissue trauma, let's say a nail enters the skin, which we'll see in just a minute, it can cause a bacteria, virus, protozoal infection, fungus infection, and the list goes on and on. This triggers a histamine release in our body. The histamine release causes a fever or pyremia, which is heated blood basically. The fever causes the capillaries and arterioles to dilate and become more permeable, so it doesn't let any other substances in. And this, when that happens, we have all these neutrophils and basophils and eosinophils. They will go in and out of the blood vessels, and this causes like the pus or exudate. That's what we call it in medical terms, but you may know it as pus or mucus that happens in sores. And then after that, we have the healing process that produces fibrinogen and eventually causes the blood to clot off and the area to scab. So that's exactly how the body handles any type of foreign invader. And the next slide shows you a nail in the skin, probably more than likely of the foot. Okay, so let's go on to the slide that says suppurative inflammation. This is slide 16. This suppurative means pus or pus forming. So this includes any pyogenic bacteria. Pyo, again, that's the medical term for pus. So pus forming bacteria is a suppurative inflammation. This is going to be like boils, abscesses, cysts, styes. And the only way that those will go away is if we kill the microorganism that has come into the body. Alright, going on to slide 18 of 85, let's kind of break down the immunity a little bit more. Acquired immunity is a response to a specific pathogen, so it's something that you're going to be exposed to or given. So we have passive acquired immunity, we have active acquired immunity, and then we have your immunizations. So passive acquired immunity is when a person receives a protective substance produced by another human or animal. So you may receive, like, let's say you got bit by a venomous snake. When you go to the hospital, they're going to give you the antivenom for that. So that's kind of a passive acquired immunity. Or maybe if, to give you a better example really, if somebody has allergy injections, those allergy shots are actually the same thing as the allergen, it's just in a less form. So an allergy shot is a perfect example of a passive acquired immunity. Then we have the active acquired immunity, and this develops following direct exposure to the pathogenic agents. So, there's a gazillion strains of viruses and colds and flus and all kind of other things. Once we have one strain of the cold, we will never ever have that strain again, because our body has cells that are called memory cells that remembers that infection and it won't happen again. And then we have vaccines or immunizations, and these are actually given to the patient, usually in anywhere between 1 to 5 doses in a lifetime, to prevent them from being exposed to the disease. So it kind of tricks the body or the immune system into believing that this pathogen is already in the body, and so we won't get it, the actual disease, like measles, mumps, rubella, polio, hepatitis. All of those are things that we get vaccinated for. Okay, and then we go into cellular immunity. This involves the production of T cells, which are very important in HIV and AIDS, which we'll talk about in a little bit. We have natural killer cells. These defense cells are called cytotoxic, meaning that they are killer cells. Cytocell toxic means, in this case it means killer cells, pretty much. They physically attack and they destroy the invader. Now let's go on to humoral immunity. This refers to the production of B lymphocytes, and we also call these B cells. These respond by producing a protective protein, which is called the antibody that I already touched on. So this is where your antibodies come into play with humoral immunity. Make sure that you look over table 2.1 in your textbook, the different types of immunoglobulins. I do want to make sure that you know that. Let's look at slide at slide 26. The physiology of the lymphatic system, just to see everything that it does. It collects excess tissue fluid throughout the body and returns it to the circulatory system. So it's going to act as a humongous filter everywhere in the body. It assists the circulatory system in transporting substances through the blood and through the body. It serves against the invasion of pathogens, and the vessels that are around the small intestines pick up those absorbed fats for transport. Let's look. I want to skip all of these different body parts associated with the lymphatic system, but do look over them. Let's go on and skip to slide 37 and talk about immunity a little bit more. The T lymphocytes, these include your cytotoxic T cells, or your killer cells, your helper T cells, and your suppressor T cells. So, like I said, T cells are a big thing with HIV and AIDS infections. When T cells are lower, this is a big indicator of HIV and AIDS. So, cytotoxic T cells are our killer cells, and they will attack the organism and invade the organism to kill it. The helper T cells kind of act as defense, so the killer cells are not kind of overwhelmed. So the helper T cells help the new microbes that may be coming in from getting far. And then your suppressor T cells are kind of like your memory cells. They remember what's happened. And then your B lymphocytes are activated by antigens. So these are going to happen once the virus or the bacteria is killed, hopefully. Your B lymphocytes are going to come in, and they're going to be converted to antibodies and then immunoglobulins. So the B lymphocytes are important as well to be healed. We're going to skip over all this real quick. And I do want you to know all of this, but there's just so much information. It's hard to cover it all. I do want to go over the various types of sensitivities, hypersensitivities. The first one is anaphylaxis, which is you may have heard of anaphylactic shock. This is something due to an allergen. It's life-threatening, and most of the time, if you don't have an epinephrine